Okay, I hope this works. Maybe I should just make sure. I'll just trust that it works. What I'm going to talk about now is language. That did not work. Why did not? Is this not the width? No, it's not the width. This is the width. Language modeling. And it's gonna be not the architecture or the transformers, but just the setup. So we had this idea previously of MNIST. It was called supervised learning. So we had supervised learning, where we had a probability distribution over X and Y, and this could be images and their labels. They came from a set X and Y, and we wanted to learn this conditional distribution of the label given the image, and this is the data distribution. And then we viewed this data set of like images and their labels. This is some kind of image as a sample. So we download MNIST, we get a bunch of images and their associated labels 0 to 9, and we say this comes from some kind of data distribution like this, and we now want to think about this conditional distribution, and therefore we have a conditional data distribution and a conditional model distribution, or a model conditional distribution, but this we call Q. It gives us the ability for each image to produce a prediction of the next label. Now with language, so language, we think of some sequences of words. So now I want X to be the set of all words in the dictionary. So it's gonna be and beta and car and so on. So this is the set X, and now we have a distribution over sequences of words. So there is a notation that's called star. It would then be all finite sequences of elements from X. So it will contain all these sequences. For example, hi there, but it will also contain a beta there. Weird sequences. All these possible sequences of different lengths, and we could also think, instead of just modeling the sequence of length t. So we have some length t, and we just care about all these. And then if we imagine that there is some kind of special word that's called maybe empty space or something, then hi there could just be, if t was 5, it would be kind of hi there space 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 or something. So then we could have a fixed length. In any case, we can imagine these kind of sets of sequences, and now we can imagine then a probability distribution on it. So there's a probability distribution going from the set of sequences to a probability. So in other words, we could say something like P of hi there. It has some likelihood, and there is then the product rule that I mentioned in the other video, where you can say P of x comma y is equal to P of y given x times P of x, or you can flip them around, it's symmetric. And this comes from the definition of conditional, where you have to divide by P of x over to the other side. And this also means that if you have x1, x2, x3, three variables, then you can say in some order, whatever order you choose, you can kind of say product of 1 times product of the previous times the previous stuff times P of x3 given x1 and x2. So the way we think of language modeling is we have this distribution over sequences. So I will write like it is almost like a vector, a list. So it's the same as x1 to xt for some t, and that's where it gets a little depends on how we think, if it's a variable or not. So maybe I will just for now view it as we have like a very large size t, and we just have these spacing things. So I will write a big T here, and that is then factored like this. So you can kind of you multiply from t small t equals 1 to t of P of xt. Yeah, I think it's actually better to have it a bit larger. It's a bit unstable otherwise. And then x1 up to xt minus 1. So like that. That is the distribution over sequences. So this is just saying there exists some distribution out there in the world. That's what we kind of imagine, that there is some kind of distribution from which we can draw random sequences of text. And this is just another way of writing it, where we write all of the individual variables, and it's a joint distribution over this. And using the rules of probability theory, we can do it. We can say that we will think of it as a product of conditional distributions. And in this way, we're choosing that we are going forward in time. We're saying x1, and then what is the probability that the next token will be a certain thing, or next word, given that the previous word was this, and then what is the probability that the third word will be something, given that the two previous words were something. And this is the important part of a lot of language models, that we are very interested in this thing that we just said. And I will write x1 to xt minus 1 as just this notation, x less than t, and then maybe a hat so you can know that it's a sequence. And so just again to think about what it is, I will abuse the notation a bit as a colon here. So we are having a sequence in of some length. Maybe it is variable length, but we could also, I'm just thinking about how rigorous to be. I think it's okay. We're getting a sequence, and what are we outputting? We're outputting a we will have to keep it. Ja.
Har du set min sorte bibel?
Nej.
Den ligger ude for et tidspunkt.
I'll just have to say like, yeah, I will not do this, like, because essentially this is a conditional distribution. So if you really wanted to think about conditional distributions like that, you would have to write something like, you're giving a sequence and you're giving the sequence the token that you're interested in, and you will get a probability. But I think this might be just more confusing than just saying like, we give some sequence and we want an output distribution. What is an output distribution here? So when we have MNIST, we have the numbers from 1 up to 9, and we give some kind of probability for each, and they sum to 1. So it is in essence a list of numbers, etc. And it's in a sense a vector in R10 with the requirement that they're positive and they sum to 1. When we have a language modeling problem, we are saying, give me a list of tokens of words and I will get you a giant finite probability distribution over all the words in the dictionary. And the dictionary is the set of words X. So this is hi, this is love, this is car, this is exclamation point, and maybe there's also something for the white space thing. So this is what we want. So P of xt is the, in the world, when you see this sequence, there's certain likelihood of this. And we want now is again another distribution Q of xt given the previous tokens that also outputs this thing. And we are interested in learning this thing. So how do we do that? We say, in MNIST, what did we do? We said we want to learn some kind of thing that works like this. This is not usually how we do it, even though we ought to. P, Q. It is the how surprised are we when we have to predict the label Y for an image X. When we sample X and Y from the distribution of pairs in the world, in the data distribution. And maybe this is a bit, this is kind of like Y of X and QY of X. This was MNIST. We are interested in a similar thing. We want to say, like, I have some kind of data distribution and I have some kind of model of text of the conditional. And now I'm gonna draw what? I'm gonna draw prefixes, like the previous sequences and the current word from my distribution over text, and I'm gonna try to be as little surprised as possible. So I want to measure my surprise. Something like this. This is one way to look at it. And another way is to think that I actually want a full distribution. So I'm saying I'm looking at the expectation over just all these sequences, and I draw them from some dataset distribution, and I'm just have this distribution over sequences in general. I can, for any sequence, I can say what probability I assign to it, and then I'm gonna be a certain level of surprise to see the sequence. And the reason is that, as we say, this can be viewed as a product here of a bunch of conditional distributions. So this will kind of end up being the same thing. So maybe I will say like approximation. It's not like, I'm not saying that it's an approximation, it's just like roughly the same idea. This might be a bit more, and then you expand it, and then you get out that you're getting all of these. So the cross entropy is our formulation of what we want to do. We have language in the world, and we want to model it with Q. We want to learn Q. So this is everything, I think.